Hello everyone. Today I am going to discuss the differentiation concepts, some methods to differentiation, some methods to differentiate our different function, and some examples defining the method of differentiation. So I am Dr. Bharat Kesari Swami and I am going to start. So these are some contents. First, the definition of a differentiable function, important derivative formulae, chain rule, then differentiation by substitution, then differentiation using logarithm, then implicit differentiation, differentiation of parametric functions, and differentiation with respect to another function. So these are the topics I am going to discuss. So first, the definition of a differentiable function. So what the definition? A function f is said to be differentiable at a point A if the limit, that is your limit h tends to 0, limit h tends to 0, f a plus h minus f of a divided by h. If this limit exists, then we say that function is differentiable at the point A. And if this limit exists, we denote it as f dash a. F dash means this is the differentiation of f and it is called first derivative at a point A, that is your f dash a. And another point is that this limit exists means it must be a finite value. Okay, the limit value must be finite. Then we say that this is the differentiation of function f or derivative of f at a point A. Okay, now this is the definition of standard definition, and we take it as f dash means derivative of first derivative of f, and another notations, if we write y equal to f of x, then this is written as dy by dx or df by dx. And operator, using operator also you can denote it as d of fx, capital D of fx. So capital D means what? Capital D is your d by dx. If we differentiate with respect to x, then capital D is your d by dx. Okay, and for the higher order derivative, we denote it f double dash, then f triple dash, or like this. Now, one thing already we have discussed in the previous lecture, that if f is differentiable, at a, then f is continuous at a. That means if we check f is differentiable, then automatically it will be continuous at that point. Now, some basic formulae that we have to remember. This is the power rule, d by dx of x to the power n, that is your n into x to the power n minus 1. Then derivative of a constant is always 0. Then derivative of c into fx, if c is a constant which is multiplied with f, then we can differentiate this as c, then just take out the c and just differentiate your fx, and it will be f dash, so c into f dash x. Now this is the sum or difference rule, that is d by dx of fx plus gx, it will be f dash plus g dash, or if it is fx minus gx, then its derivative will be f dash minus g dash. And one more example is, if we have to differentiate d by dx of 3x to the power 4 minus 2x square plus 7, then what will be this? Just use your power rule. Okay, so 3 is constant, just take 3, and derivative of x to the power 4 is, according to this formula, it will be 4x cube, 4x cube, and previously 3 is multiplied, so it is 12x cube. And for the derivative of 2x square, it will be 4x, because the derivative of x square is 2x according to the power rule, so it will be 2x, and 2 is there, so just multiply it, and it will be 4x. So minus 4x. Now derivative of 7, this is a constant, so it will be 0. So result is 12x cube minus 4x. Okay, this is a simple problem, like using your sum or difference rule and your power rule and constant rule. Okay, now these are some another standard derivative formula. You just remember all this formula, you just note down all this formula: exponential function, how to differentiate exponential functions, how to differentiate logarithmic function, how to differentiate the trigonometric functions, how to differentiate your inverse trigonometric function. There are some formula, you just note down this inverse trigonometric function. Okay, so these are some standard formula we have to remember. To do the problems, we have to remember, just note it down. Now come to product rule. So what is the product rule? If u and v are two differentiable function, if ux and vx are two differentiable function, then dy dx of the product ux into vx, dy dx of ux vx will be what? U dash plus u dash into v plus u into v dash. That means you just differentiate u first, then multiply it with v, and plus differentiate v and then multiply u. So the formula is what? D by dx of uv equal to u dash into v plus u into v dash. So using this formula, you can differentiate this type of function. Suppose y equal to x square into sin x. So x square is a function, sin x is another function, both are differentiable, and if we have to differentiate this product, then we can apply this formula. That means first, what will be y dash? This is your y. So y dash means first derivative. So first derivative is how to differentiate. Just sin x will remain same, then differentiate x square. Sin x is remain same, and differentiate x square, so it is 2x according to power formula, and then plus keep your x square constant, means keep your x square as it is, and take the differentiation of sin x, so derivative of sin x is cos x. So the result is this. Similarly, this is also a product. Suppose y equal to e to the power x into ln x, then what will be the differentiation? Y dash will be equal to e to the power x ln x. So keep ln x as it is and differentiate e to the power x. So differentiation of e to the power x is again e to the power x. Now plus e to the power x as it is, then differentiation of ln x. So keep one function as it is and take the differentiation of another function. Okay, so this is the product rule. Now the quotient rule is what? Dy dx of u by v. Already we have discussed in the previous lecture. Just one or two more example I want to discuss here for your better understanding. So dy dx of u by v. So what is the formula? U dash. What is the formula? U dash into v minus u into v dash divided by v square. So this is the formula. Now you just see, if y equal to x square plus 1 divided by x, and we have to differentiate y with respect to x. So y dash will be what? So take this x square plus 1 as u and take this x as consider this x as v. So according to formula, now differentiate. Okay, so suppose we consider x as v, so x is remain constant. So x, then derivative of x square plus 1, which is 2x, then minus x square plus 1 will remain same, then derivative of v means your x, so derivative of x is 1 divided by v square, so v is considered as x, so this is divided by x square, is not it? So similarly you can differentiate sin x by e to the power x, sin x e to the power x, so consider sin x as u and e to the power x as v. Same formula, just apply this. So v into u dash, so v is your e to the power x, and what is your u? U is sin x, so differentiate sin x, so this is your cos x, minus u into v dash, so u is your sin x and v means your e to the power x, so v dash will be, that means your derivative of e to the power x is again e to the power x divided by v square means v is your e to the power x, so e to the power x whole square. So this is how we have to apply the quotient rule. So we can differentiate the quotients, we can differentiate the this rational type of rational functions using this quotient rule. Now come to the chain rule. So it is very important. So what is the chain rule? Suppose y is a function of, means y is f of g of x, means y is what? F is the function f, and which is again a function of a function of x. That means f is a function of g of x. It's a composite function. F is a function of g and g is function of x. And both f and g are differentiable. Then how to differentiate? How to find dy by dx? Suppose y equal to this. So how to differentiate this? Because if we differentiate, if we want to derivative, or we have to differentiate y with respect to x, then see, y is not a function of x, it is function of g of x. So directly we cannot differentiate, because with respect to x we have to differentiate. To differentiate with respect to x, y must be a function of x only. But here f is function of g, y is a function of y is f and f is a function of g of x. So to find dy by dx, first what we have to do, we have to differentiate, because it is a function of gx, so we have to do what? D by dx. We have to do d by dgx. We have to differentiate with respect to gx. This is your f. That means d by d of gx into, again we have to differentiate your gx with respect to x, because g is a function of x. Understood? Again I want to repeat, since y is your f and f is a function of g, okay, and if I want to differentiate y with respect to x, I cannot differentiate directly because y is function of g. So first what we have to do, we have to differentiate with respect to g of x first. This is your f of gx. Then again we have to differentiate your gx with respect to x. we have to differentiate your gx with respect to x. This is the chain rule. Okay, got it? So here it is written as, this is your dy dx of gx, sorry, dy dx of f, that is written as f dash, and again we have to differentiate g with respect to x, that is your g dash x. Okay, so what is the application here? Suppose y equal to sine of x square. Suppose y equal to sine x square, and we have to differentiate with respect to x. That means dy dx of sine x square, dy dx of sine of x square. Okay, so see here, this is not sine x, this is sine of x square. That means we can consider it as dy dx of sine fx. It is not x, it is fx. Okay, so just remember what to do. Just differentiate this as your previous formula. Just differentiate it as your previous formula, because sin fx, what is the formula for sin x? It is cos x. So since it is sin fx, just write it as cos fx. Cos fx. Then again differentiate your fx. This is the rule. As your previous formula, just differentiate it, and again this fx can be differentiated with respect to x. Okay, so since it is sine x square, so what will be the result? First take the derivative of sine x square. So sine means its derivative is cos, so cos x square. Then again differentiate x square, that is your 2x. Okay, so dy dx of sine x square means, dy dx of sine x square means cos x square, derivative of sine x square means cos x square. So since it is not x, consider this as fx. So again derivative of x square means 2x. So this is the result, and this is also your chain rule. That is what to do. Okay, similarly just see e to the power 3x square plus 1. Differentiate y, that is your e to the power 3x square plus 1. E to the power 3x plus 1 means here it is not e to the power x, because we know that dy dx of e to the power x is equal to e to the power x. But here this is your e to the power 3x square plus 1. dy dx of, suppose, e to the power fx. Consider this your x square plus 1, 3x square plus 1 as fx. So what will be the formula? E to the power fx as it is. Okay, e to the power fx. Then since it is not x, it is fx, we have to differentiate fx again. So in every formula we can apply this. In every formula, if fx will be there in place of x, then you can differentiate like this. So e to the power 3x plus 1 means it will be e to the power 3x plus 1. This is the result, e to the power 3x plus 1 again. Then again differentiation of 3x square plus 1. So again derivative of 3x square plus 1. So what it will be this? It will be 3 is constant, so derivative of x square is 2x, so 6x, and derivative of 1 is 0. So the result will be 6x. Okay, similarly you can do like this. You can also solve this. This is your ln not fx, this is your ln fx. Consider this as fx. Consider this as fx. So ln fx, so derivative of ln fx means we know that ln x, derivative of ln x is 1 by x. Okay, derivative of ln x is 1 by x. So here it is fx. So your formula will be 1 by fx. The formula will be 1 by fx, and again differentiate fx. That means dy dx of ln fx. Okay, So just write it as 1 by fx according to formula, and since it is fx, we have to differentiate again d by dx of fx. So this is the result, 1 by x square plus 1 root over, then again differentiation of 1 by x square plus 1 root over, and that will be x by root over of x square plus 1, and multiply this, it will be x into x square plus 1. Understood? So every formula, every standard formula here, all this formula can be written like this. All this formula, this is standard formula, and you can write x, means you can write fx in place of x. In every formula we can write fx, replacing your x, replacing x. If you replace x by fx, then your formula will be same, but in place of x just put fx and again differentiate fx. That is the rule. Okay, suppose e to the power d by dx of a to the power x is a to the power x ln a. Suppose we write d by dx of a to the power fx, then what will be the formula? It will be a to the power x, in place of x just write fx into ln a. Okay, a to the power fx into ln a, and again differentiate fx. Okay, so every formula we can do like this for every formula. Now come to differentiation by substitution. Differentiation by substitution. Okay, so what is the example? Just explain. I can want to explain it by through an example. So what is the example? Find d theta by dt if tan theta equal to 1 minus t divided by 1 plus t. So tan theta is given, and we want to find d theta by dt. Now, using substitution method, how to differentiate it? Okay, so see here, if I substitute t equal to tan alpha, then what will be tan theta? Tan theta is 1 minus tan alpha divided by 1 plus tan alpha. Is not it? So tan theta equal to 1 minus tan alpha divided by 1 plus tan alpha. Now use the identity. We know that tan a minus b is equal to tan a minus tan b. This is a trigonometric identity, divided by 1 plus tan a into tan b. Now see here, we know that tan theta, this written as 1 minus tan alpha, this can be written as tan pi by 4 minus alpha, because in place of 1 we can write tan pi by 4. So tan pi by 4 minus tan alpha divided by tan pi by 4 okay, into tan alpha, and this is 1 plus, so tan a minus tan b divided by 1 plus tan a into tan b, isn't it? So tan theta will be written as tan pi by 4 minus alpha, according to or using the identity. So since tan theta equal to tan pi by 4 minus alpha, so theta will be pi by 4 minus alpha, and alpha will be tan inverse t. Okay, so because your t equal to tan alpha, what is your alpha? It will be tan inverse t. So just we have to find d theta by dt. So what is theta? Theta is your pi by 4 minus alpha. What is your theta? Theta is your pi by 4 minus alpha, and alpha is your tan inverse t. Alpha is your tan inverse t, is not it? So now what will be d theta by, here check here, d theta by we have to find d theta by dt. So d theta by dt equal to d by dt of alpha 5 by 4 minus alpha, and if you differentiate it, because yes, using difference rule, 5 by 4 is a constant, so derivative will be 0 and it will be only minus d by dt of alpha. So d theta by dt will be equal to minus d by dt of alpha. Now we have alpha equal to tan inverse t, alpha equal to tan inverse t. So d theta by dt, so d theta by dt will be minus d by dt of alpha, and alpha is equal to tan inverse t, alpha equal to tan inverse t. So that will be direct, use the formula, inverse trigonometric formula. It will be 1 by, minus is there, 1 by 1 plus t square. This is the answer. Okay, so this type of problem can be solved using the substitution method. Now come to another problem, that is your differentiation using logarithm. This is another method, and it is very useful when the function is a product or quotient or has a variable exponent. And what is the procedure for this logarithmic differentiation? Take logarithm on both sides, take logarithm on both sides and simplify before differentiating. Suppose y equal to fx is given, take log on both sides, so ln y ln fx, and differentiate using chain rule. So it will be ln y means 1 by y and dy by dx, and this is the differentiation with respect to x on both sides. So 1 by y into dy by dx, and the right hand side dy by dx of ln fx. Okay, so we have to find dy by dx. So just y in the left hand side, y is divided, so just multiply in the right hand side. So if you multiply y on both sides, so we will get dy by dx is equal to y into this. So this is the procedure to differentiate the function using logarithm. So just try this example. So what is the question? Find dy by dx if y equal to x to the power x. See here, it is a variable exponent, x to the power x. So when function is given like this, suppose it is a product or quotient or variable exponent. So here exponent is a variable, x to the power x. Okay, so and we have to find dy by dx. So y equal to x to the power x is given. So take ln on both sides, take logarithm on both sides. So it is ln y and ln x to the power x. Ln y equal to ln x to the power x, and we know that your exponent will be multiplied when logarithm is there. So exponent is multiplied, so x into ln x. Okay, so ln y equal to x ln x. Now differentiate on both sides. Differentiate on both sides. So if you differentiate in left hand side using chain rule, ln y means 1 by y and dy by dx, because we have to differentiate with respect to x. So 1 by y into dy by dx. This is your 1 by y dy by dx, and derivative of x ln x, you use your product formula, ln x will be there, into derivative of x is 1, so ln x only, plus now keep x as it is, then derivative of ln x means 1 by x, so x will be cancelled, only 1 will be there, so ln x plus 1. Thus what will be dy by dx? So dy by dx is just multiply y on right hand side and left hand side also, so it will be y into ln x plus 1, and since y equal to x to the power x, so in place of y put x to the power x. So your result will be x to the power x ln x plus 1. Okay, so this is the procedure how to use logarithm for differentiation. Another example is there, y equal to sin x to the power tan x. Same procedure, sin x to the power tan x. So take ln on both sides. Take ln on both sides. So tan x is exponent, so it will be multiplied. So ln y equal to tan x into ln sin x. Is there any doubt? No. Next, so differentiate on both sides now. This is the procedure. Take ln on both sides, then differentiate on both sides. Then differentiate on both sides. So if you differentiate, ln y will be 1 by y into dy by dx. And take differentiation of this. So again, this is the product formula because tan x into ln sin x. So for this differentiation, just take ln sin x as it is. Then derivative of tan x is x square x. Then keep tan x as it is. Then derivative of ln sin x. So derivative of ln sin x means again chain rule because ln of fx. Ln sin x means ln of fx. So ln fx means what is the formula? 1 by the ln sin x. Derivative of ln sin x means you can write like this, dy dx of ln sin x, and it will be 1 by sin x into derivative of sin x into derivative of sin x. So it will be what? Derivative of sin x is cos x, so cos x by sin x, so it is cot x. Okay, so final result will be 1 by y dy by dx x square ln sin x plus tan x into cot x, and tan x into cot x is 1, so it is 1 by y dy by dx x square x ln sin x plus 1, and we have to find dy by dx only. So take dy by dx in your left hand side and take your y to the right hand side, so it will be multiplied. So the final result is this. Final result is dy by dx is equal to this. Okay, now another type of differentiation. This is your implicit differentiation. Come to implicit differentiation. So what is your implicit function first? A relation where y is not isolated. If it is given like this, f of xy equal to 0, because explicit function is written like this, y equal to fx. Explicitly it is given by x. Explicitly it is given y equal to function of x. But when this function, explicit function written like this, fxy equal to 0, then it is a implicit function. Suppose we have y equal to 2x. So this is implicitly given. But if I write this as 2x minus y equal to 0, now this is a function of fx. This is a function of xy, fxy equal to 0. Now this is written implicitly. This is explicit form and this is implicit form. Understood? So here implicitly function is given. Then what is the procedure? To find dy by dx, just differentiate with respect to x, treat y as a function of x and apply chain rule. Then collect all the dy by dx terms and solve this. This is the procedure. Okay, so consider example. So question is given x square plus y square equal to 25. This is a implicit function and we have to find dy by dx. We have to find what? Dy by dx. So differentiate on both sides. This is the procedure. Differentiate on both sides. So dy dx of x square, dy dx of y square, dy dx of 25. So dy dx of x square means 2x. Dy dx of y square, because y is a function of x, so it is according to chain rule 2y into dy by dx, and derivative of 25 is 0. So 2x plus 2y into dy by dx equal to 0. Now we have to solve for dy because we have to find dy by dx. So solve for dy by dx. So dy by dx will be what? Solve it only minus 2x by 2y minus 2x by 2y, 2 cancel, so it is minus x by y. Another example, suppose e to the power xy equal to x minus y. E to the power xy equal to x minus y, and we have to find dy by dx. dy by dx. So differentiate on both sides. Okay, dy by dx of e to the power xy, then dy by dx of x minus y. So dy by dx of e to the power xy will be what? E to the power xy, because using chain rule, dy by dx of e to the power xy, that means e to the power fx. So what will be formula? E to the power fx into derivative of fx. So e to the power fx means e to the power xy, then derivative of xy. So using product formula, it will be x into dy by dx plus y into dy by dx of x. So it will be what? X dy by dx plus y only. This is the similarly differentiate of means derivative of x minus y will be 1 minus dy by dx. Now equate this, solve for dy by dx. So take all the term having dy by dx. That means dy by dx is there. Here is a term having dy by dx. Here is a term having dy by dx. So take all this term to the left hand side and all the term having not dy by dx, so to the right hand side. So dy by dx equal to this and this. Take dy by dx common and solve for dy by dx. Solve for dy by dx. So this is how we can solve the implicit function, differentiation of implicit function. Now come to another type of functions, that is parametric function. So differentiation of parametric function. So parametric function means what? Parametric form means your x and y are given in form of t, in form of a parameter t. So what is the procedure to find dy by dx here? Just differentiate x with respect to t, because x is a function of t, y is also a function of t. So separately differentiate x and y with respect to t. So first find dx by dt, then dy by dt, then divide to find dy by dx. So divide dy by dt by dx by dt, and it is valid only when your dx by dt is not equal to 0. If dx by dt equal 0, then it will be undefined. Okay, so let's come to an example. So given x equal to t square, y equal to tq. Simple example is x equal to t square, y equal to tq, and we have to find dy by dx. So what to do? Just differentiate x with respect to t separately, differentiate y by derivative of y with respect to t, then divide. So dx by dt will be what? 2t. Then derivative of tq means 3t square. So dy by dx will be just divide 3t square by, because dy by dt divided by dx by dt, dy by dt divided by dx by dt. So 3t square by 2t, and just cancel t, and the final result will be 3t by 2. Another example is there. I want to discuss that. Suppose again this type of x equal to a cos t, y equal to a sin t. Again x is given as a parameter of t, and y is also a function of parameter t. So same thing, just differentiate with respect to t separately, then differentiate y with respect to t. So a cos t means a is constant, so derivative of cos t is minus sin t, and a sin t means a is constant, derivative of sin t is cos t. So now to find dy by dx, divide dy by dt divided by dx by dt. So dy by dt is a cos t divided by minus a sin t, and the result will be minus cot t. Okay, now another type of differentiation. Next is differentiation with respect to a function. So if y is a function of t, x is a function of t, that is g of t, and we have to differentiate y with respect to x, and this is the procedure what we have to means what we have discussed earlier. What is the general principle? Suppose we have to differentiate with respect to a function, that means not with respect to x, with respect to phi of x. So what to do? First differentiate y with respect to x, and with respect then differentiate the function with respect to x again separately and just divide. That means suppose we have to differentiate d by d g x and d of fx. Suppose we have to do derivative of fx with respect to gx, derivative of a function with another function with respect to another function. So what to do here? What to do here? Just differentiate f with respect to x separately, then differentiate g with respect to x separately, then just divide, then we will get the answer. Okay, come to an example. So dy by d of e to the power x, that means we have to differentiate y with respect to e to the power x with respect to a function e to the power x. So what to do here? Y is given, y equal to ln x plus 1. So what to do here? Differentiate y with respect to x. This is the procedure. What to do? Differentiate y with respect to x separately, then differentiate e to the power x with respect to x and divide it. Okay, so dy by dx will be what? 1 by x plus 1, because ln x plus 1, derivative of ln x plus 1 means 1 by x plus 1, then derivative of e to the power x is e to the power x, then just divide it. So dy by dx, then e to the power x, and the result will be 1 by x plus 1 into e to the power x. Understood? Another example here. Differentiate, this is the problem. Dy means this is what? Derivative of tan inverse x with respect to cos inverse x. Derivative of tan inverse x with respect to cos inverse x. So what to do here? What to do? Just take dy tan inverse x with respect to x divided by dy dx of cos inverse x. Simple. Divide x of cos inverse x. Okay, so here check. Divide x of tan inverse x is 1 by 1 plus x square. Divide x of cos inverse x is minus 1 by 1 minus x square root over, and the result will be what? Result will be, just divide it, 1 by 1 plus x square divided by minus 1 by root over of 1 minus x square, and the result is this. Okay, so this is the differentiation of a function with respect to another function. With respect to another function. So one more example I want to discuss. It's a very important example for plus 2 students. That differentiation of x to the power y equal to y to the power x. That means we have to find dy by dx. If x to the power y equal to y to the power x, it is given, and from this find dy by dx. So since it is having exponents, x to the power y variable exponent, again y to the power x, so take natural logarithm on both sides. So it will be y ln x equal to x ln y. Take ln on both sides, ln of x to the power y equal to ln of y to the power x. So y ln x equal to x ln y. Now differentiate with respect to x. So derivative of y ln x means, according to product formula, it will be y dash into ln x plus y by x. Then derivative of x ln y means ln y remains same, derivative of x is 1. Then x into derivative of ln y, derivative of ln y means 1 by y. Then again derivative of y means y dash. So x into y dash by y. Now equating the derivatives, take your left hand side and right hand side, the result will be this. And now since we have to find y dash, that means dy by dx, so take all the terms to the left hand side having derivatives, having y dash. So take the terms having y dash to the left hand sides. So it will be y dash ln x minus x y dash by y, and the remaining terms to the right hand side. So ln y equal minus y by x. Then solve for y dash. Take y dash common, so ln x minus x by y, and that is equal to ln y minus y by x. So the result will be dy by dx equal to ln y minus y by x divided by ln x minus x by y. So this is an important problem for plus 2 students. So thank you, and if there is some questions, I welcome, and we will discuss if there is any doubt. Thank you again for watching the video, and try to subscribe and see the channels, see the videos, and share the videos to your friends, and subscribe the channel also to see this type of discussion, this type of problems. Thank you.